In this video, I'll be defining what enthalpy of formation is. Enthalpy of formation. And it is represented with a delta, H, and F here, and a 0 here. So that is the symbol for enthalpy of formation. And whenever you hear the word enthalpy, you will want to think about heat flow. This is enthalpy. However, the enthalpy of formation is a little bit more specific. It refers to, I should write it a little smaller, the heat flow that transpires upon synthesis of exactly 1 mole of compound in standard state. And I forgot a D here. Alright. So it is a very specific definition. However, keywords you should know: heat flow, enthalpy. Synthesis means that 2 elements will form a compound. 1 mole, keep that in mind, in standard state. And well, if you don't remember, standard state represents, so standard state a pressure of 1 atmosphere and a temperature of 298.15 Kelvin. That is 25 Celsius, if you remember Celsius. Now let's go back to our definition of enthalpy of formation. We said that it refers to the heat flow that transpires upon synthesis of exactly 1 mole of compound in a standard state. So, if you're looking at the enthalpy of formation of an element in a standard state, say just something like, let's go with oxygen. In its standard state, you will have an enthalpy of formation of delta H F naught 0. And if you think about it, it really makes sense because there is no synthesis going on, and the element is just in its natural state, so there will be no heat flow occurring. So keep in mind, in an elemental in its elemental form, an element will always, in its natural state, an element will always have an enthalpy of formation of 0. And that will be very helpful when you have to start using calculations in your thermal chemistry. Now I'm going to go through a series of reactions, so just to make sure that you understood the concept well. Now I'm going to make up 3 reactions, so don't freak out about the numbers, they're just made up. So let's use the reaction we've always used. We have sodium and chlorine forming NaCl. I'm going to write the same reaction 3 times and then just modify it. I'm going to say that in these 2 cases, chlorine is in its gaseous form, so it's diatomic. And in this one, it is also like that, but actually no. This one is going to be an ion. So the sodium is going to be an ion. In the second one, I'm just going to balance the equation regularly. So we put a 2 here, and that looks horrible. Two. So we just put a 2 here. And in the last one, I'll just put 1/2 in here. So if you look at it, this is going to be 1, this is going to be 2 over 2, which is 1, so this is balanced. You can balance like equations using fractions as well, because they're not very common. And only one of this is right about the enthalpy of formation. And the way to figure it out is just by looking at the definition again. So we said that we want the synthesis of 1 mole of compound in its standard state. So the first thing we realize is that there's a 2 here. So we're forming 2 moles of compound. So that rules this one out. And then we never talked about ions before. And when you look at this one, it's only forming 1. It's a synthesis, and the elements are in their standard states. So when we look at ions, the first thing you want to do is take that one out, because there will be no enthalpy of formation. So actually, the only right one is this one. Again, only 1 mole is synthesized, and the elements are in their standard states. So don't assume because an equation has fractions, it's wrong. You have to look at all the factors.